right, let's go ahead. We're going to get into finding limits algebraically. Okay, so there's going to be two examples that I sort of want to discuss that we can sort of, just before I get into the official examples. Okay, so first example I want to discuss is, let's take the limit as x approaches 1 of x. Okay, this one is perfectly, let's say, easy, okay, in the sense that there's nothing to do. We just plug 1 into x and we get 1, okay? Easy peasy, whatever, okay? Now, let's contrast with limit as x approaches 1 of, let's take x times x minus 1 divided by x minus 1. Okay, now what happens in this second case? Well, we can actually divide the x minus 1, okay, and we still get 1. Okay, but these are two fundamentally different things. Okay, on the left-hand side, x equals 1, that's simply this line. Okay, on the right-hand side, however, we get something slightly different. Okay, what happens is at 1, 1, we're going to have this open circle. We have a hole there. Okay, and then other than that, it's the same thing. Okay, so just keep in mind the slight difference between them. I need to get that hole a little better. I guess it's not going to let me, so there we go. Okay, so they are slightly different, and I want you to keep those in mind. In this situation, the idea of a limit doesn't really do much for us. But in this situation, the idea of a limit gives us a lot more we can work with. Okay? All right, so keep those in mind as we move forward. Start with number 10. Number 10. So number 10 says the limit as x approaches 3, negative 7x plus 1. Okay, so this is just that first case. There's nothing crazy going on in this function. And what's going on, even if there's just nothing crazy going on. So I could just plug 3 in. So what do I get? Negative 21 plus 1, negative 20. That agrees with the answer that I have written next to the problem in the book, so I'm good. Okay, next problem. Number 12. Number 12 is the limit as x approaches negative 1, negative 3x squared plus 5x plus 1 equals. Again, there's nothing crazy going on here. Okay, nothing crazy going on. Okay, so that's just going to equal, I'm going to plug negative 1 in. What do I get? So negative 3 minus 5 is negative 8, plus 1 is negative 7. Okay, let's contrast that with 1. Let's take a 12 prime, and let's take the limit as x approaches negative 1 of negative 3 square root of x. So we're going to change that x squared to a square root plus 5x plus 1, and here this limit does not exist. Okay, this limit does not exist because the square root function is not defined at -1. Okay, there's no way to make sense of this, even near -1. Okay? Okay, there's just no way to make sense of that. Okay, so this limit does not exist. Okay, let's go with another one, let's skip name number 18. You guys can do that. Let's do number 30. Okay, the limit as x approaches 1 of the cube root of 5x plus 1. Okay, so again, we're gonna go ahead and just plug 1 in. We're gonna take 5 plus 1. Sorry, that was actually not a plus 1, that was a plus 3. Okay, 5 plus 3 is 8. The cube root of 8 is, ta-da, 2. Now, what if I had a negative here? Okay, could I put a negative number underneath the cube root? I can, can't I? Okay, let me think of a similar problem to sort of illustrate what I'm trying to say. Let's take the limit as x approaches. Let me think here for a second. Let's take -6, the cube root of 5x plus 3. Okay, so I've just changed it around a little bit. I'm making this -6. So what's that going to be? Well, I'm going to plug in the -6, and I'm going to get -30 plus 3 is -27, and the cube root of -27 is -3. So this one also still works. Okay. All right, let's go to 34. And 34 is the first one of that sort of second kind of limit. Okay, we're going to take the limit as x approaches 2 of x squared minus 4 over x squared plus x minus 6. So now our first sort of inclination is to plug the 2 in. Okay, if we plug the 2 in, what's going to happen? Well, we're going to get 2 squared is 4 minus 4 is 0. 2 squared plus 2, so 4 plus 2 is 6, minus 6 is 0. Or, there's a problem. So let's put this in red to say this means we have to do something else. Something else has to be done. Okay, now the first thing that happens is if we have 0 over 0, we can do some simplification, okay? Because if you remember from college algebra, if you have 0 over 0 when you have polynomials, that means they have a factor in common of x minus 2 in this case, right? So they should both have an x minus 2 in common. So not only do I have to factor it, but I already know what the factor is to cancel out. So we're going to take the limit as x approaches 2. X squared minus 4 is x minus 2 times x plus 2. X squared plus x minus 6 is x plus 3 times x minus 2. So those x minus 2's are going to cancel out. Okay, so we're going to get the limit as x approaches 2 of x plus 2 over x plus 3, which is going to be 4/5. Okay, we'll continue with some more problems in a new video. Once my mouse starts going. There we go.